So we're going to go through one more example here of a stoichiometry problem where there's limiting and excess reactants involved. Again, the idea is do stoichiometry twice, once for each starting amount, and be sure to solve each time for the same ending product to determine which one can produce more and which one can produce less. So in this example, again, we want to start as always with balancing the equation. This is a super easy one to balance, so we'll jump right past that part here, 2, 1, 1, 2. Now, it doesn't matter which of my two numbers I start with up here. You're going to have to do them both eventually. So I'll just start with my 43.40 grams of sodium hydroxide. And again, we're going to run it through the stoichiometry. And solve for what? And that's a really important question. If you do all this for the wrong stuff, you're going to have to go back and start over. The question's asking here, what volume of water? So we're solving for the water in this one. Okay? And so the first step, we've balanced the equation. The next step, let's as always convert to moles. 1 mole of sodium hydroxide. Go to your periodic table, since this is in grams, and add it up. And sodium hydroxide is right at 40 grams in a mole. Then we need our balanced equation to give us coefficients here for our mole ratio. And according to the equation, 2 moles of sodium hydroxide will give me, in this reaction, 2 moles of water. Okay? So that'll be on the top. So it's a 2-to-2 ratio. And then the last step, question's asking what volume of water. Okay? So we want to make sure at the end that we get to gas volume in liters. And this is coming out of steam, essentially, according to this reaction equation. It probably wouldn't in real life, but we're going to assume that we could do that. And so 1 mole of water will have how many liters? Again, that's that standard number that we use, 22.4 liters of any gas, okay, in 1 mole of that gas. And so there's our setup. All the units will cancel out and so forth. And at the end, our answer will be in liters of water. Liters of steam, essentially. And the calculator will tell me 24.30 liters of water. Now, again, if this is a regular stoichiometry problem, we'd be all done. But we need to still consider the H2SO4. How far can that one go? And so we need to start our stoichiometry again using 102 grams of H2SO4. And we're going to set it up again to solve for the same ending substance. We want to get to water on both of them. If you remember on the earlier video, sort of the idea that you're starting with sodium hydroxide and solving for water. Well, we just did that in our first problem. And now we're going to take the H2SO4 and solve for water again and figure out which one can make more and which one can make less. So our stoichiometry, we convert grams to moles. 1 mole of H2SO4 is about 98 grams or so. Always better to have an extra decimal place rather than having too few when we're rounding and stuff. In our equation, 2 moles, oh, pardon me, that's not quite right. In our equation, 1 mole of H2SO4 will form 2 moles of water. So this is a 2-to-1 ratio. And then, again, lastly, we want to get this to liters, so we need to remember that 1 mole of water is 22.4 liters of water. Okay, steam as a gas. And if I punch all this into my calculator, again, I'll get an answer. Now, in terms of my final answer here, it's going to come out around 46.6 liters of water, of steam. Now, I've got 2 answers. In fact, they're almost double each other. This one's almost double the first one. And remember, the answer, they're not both correct. Okay, you can't have 2 answers. Only one of them is correct, and it's the lesser one, because it turns out that we can only go as far as the sodium hydroxide will allow us to go. Right? The idea, again, that if I can go 24 yards and you can run 46 yards, we're only going to go 24 if we're tied together in that 3-legged race. And so in our chemical reaction, these 2 chemicals, sodium hydroxide and H2SO4, are tied together by a plus sign by a chemical reaction. And they're only going to go as far as the one of them that can go the shortest distance, or in this case, can produce the lesser amount of H2O. And so, my water is produced from, my final answer is produced from the lesser amount, and this is my limiting reactant. While the sulfuric acid, H2SO4, could have gone further, still has a little bit left in excess, in fact, probably quite a bit left in excess. This is going to be my excess reactant. And that's it. Now, there's one other angle that comes with limiting and excess reactants that we may or may not get into really soon. It's not part of this assignment, but the other part of this would be to ask, okay, well, I figured out my limiting reactant and stuff. How much of the excess reactant would be left when this reactant stops, when this reaction stops? So when the NaOH runs out, as it's going to do, it's the limiting reactant, it's going to run out and fall over like in our three-legged race. When that happens, how much of the H2SO4 would be left? And that's kind of another angle of stoichiometry. And we could say, well, all we're going to do to figure that out is start from the limiting reactant here and figure out how much H2SO4 it would need in order to react. Now, that's not something you're being asked to do here, but that's one more way we could start to look at these. And there are quite a few more, actually, with limiting and excess reactants. But for now, these two videos have taken you through the first two examples on the assignment. They're numbered problems 5 and 6. On the back of that sheet, you've got problems 7 and 8. Work on those for the next time that we see you. And if you have questions before that time, try to find us in Saber Time and get some help. We'll talk to you then.